given to me and to the podium. It's a pleasure for me, ladies and gentlemen, to have you here and that we have the chance to represent Crealet. We are now very happy that we can celebrate the 20 years anniversary during the ITMA, and we have another anniversary. 40 years ago we have shown the first warp laptop, electronic warp laptop to the market. "20 years ago, I founded together with Leo Kuster and Jörg Schmidt the company Crealet. Leo Kuster and myself worked for Willy Grob. I joined Willy Grob in 1985 and Leo was with Willy Grob together some years before. Leo introduced 40 years ago the first let-off on a rapier loom on a warp beam which was on the top of the weaving machine. It was the first one and it was very successful. The customers asked us later on to do also conversions for the ground beams, and that was a challenge because with upper beam equipment we had low tension on the machine, and with the ground beam we had higher tension, and it was not very easy to do this higher tension. What I want to tell you now is what we have done between the last ITMA and the coming ITMA. Our space in the room we had in Eschenbach, we started in Eschenbach with our production of customer-made warp laptops. It was coming too small and we had to move to Wald into a new room. You can see it here, which gave us more space for assembling of the warp laptop systems, which are coming bigger and bigger. So we moved last year, and then we took also the chance to hand over the company to the next generation. Leo's son Mario and my son Andreas, which is also sitting in the plenum here, they are now the owner of the company and they manage the company also. I'm actually retired. I only work if my son asks me for some assistance. Otherwise, yeah, I'm not in the business anymore. What are we doing? What are the customers expecting from our side? They come to us because we do tailor-made solutions for them. We don't have a standard machine, so everything is tailor-made, and they ask us for a constant fabric quality, for reproducible fabric quality, increasing the efficiency, the profitability, reduce workload, elimination of non-value added activities, easy adjustment of warp tension, monitoring and visualization of warp tension. These are requirements of our customers. And with the next slides I show you some solutions we made for customers. We are actually in the field of wide weaving and narrow weaving, and also in the field of warp knitting machines. Here on this slide you can see an upper beam equipment for a super projectile loom. On this equipment a very heavy polypropylene fabric is woven with a very high warp tension, and for that new warp tension roller has to be developed, and now the customers are weaving with this unit very successful. We do also warp beam frames which are placed behind the wide weaving machines. If you can add additional beams to the weaving machines, you can get longer running time, and that means a higher efficiency of the machine. Here it's a sample with 4 beams, that means 4 half beams behind also a projectile loom. Then for wide weaving machines, it's also a possibility to weave from creel. So we have a feeding device which is placed behind the weaving machine and in front of the creel. We pull the yarn from the creel by a take-up roller and feeding it to the weaving machine. Weaving from creel is done when the warp beams are out very quickly and the frequency of warp beam changes is very high. Then customers sometimes decide to weave from creel. Then on to the weaving machine since approximately 5 years. The loom manufacturers and the customers ask for let-off feeding or for positive feeding of the selvage thread. On the machines we have, on the machines on the left and the right hand side we have a thread feeder, and you can adjust the tension of this weft feeder. Mario and Andreas modified this older system we had to a new one with a display, so you can adjust the tension on the control and the tension will be shown on the display. When tension or high density fabric is woven, it can happen that we have a problem in the selvage area, because sometimes the selvage area is getting floppy. And if we control the selvage thread, if we give them some more tension, then we can avoid this. And the fabric you see now, that's an airbag fabric woven on a Chudakoma loom. And after that you have a straight selvage. So Dornier decided to equip all their machines which are delivered for weaving airbag looms are equipped with our units. The unit is also used on ITMA machines for filter fabrics. It's also worthwhile to have them there. So now to the products we have for the narrow weaving machines, or behind the narrow weaving machines. Last ITMA we introduced the BLDC controller, which is also on this slide, to the market, and it's actually very successful. We measure the tension of the yarn by a load cell, and gives the signal to the control unit, and the control unit drives the beam so that we have a constant tension from full to the empty beam. The beams are getting bigger and bigger, also in the narrow weaving. Here we have a customer with 6 beams, and for this solution we had to find a new way to control it, and we do it now by a PC, and we call the system we have with the PC controlled linked motion control. Onto the PC, each beam can be showed and can be adjusted to the tension you want to go, so that it can be specified for the fabric we actually want to weave. Then here we have a linked-in solution for a shuttle loom. The shuttle loom is to weave biomedical fabrics, and behind these machines are 24 small beams, and all of them are also programmable from the PC, and they can move synchronized or independent, each beam by itself. Then sometimes to improve the running time on the narrow weaving machine, also customer ask to weave from wide beams. Wide beams can be placed in a special direction behind the weaving machine. Here we have a sample with 4 beams to make the bands. They are controlled also by the control we introduced to the market last ITMA. And also feeding threads coming from the creel is used in the narrow weaving. Also in this range we have solutions customer made, and some of them are bigger, and then we have also some small ones for only 10 or 12 threads. Warp knitting is also a market for us. Here you see a solution we made behind the Karl Mayr weaving machine. Customer had already this machine, wanted to add some more beams to have also longer running time, and we made this equipment for him. The demand is different to the weaving machine. We have a much higher yarn speed, and we have to be synchronized with the weaving machine because the high speed machine run. Then there is another other application for 2 beams, also for a Karl Mayr machine, and on this unit we have the first time the new LCM controller, which was developed last year. And now I'm coming to the ITMA. What are we showing at the ITMA? We have developed a new control unit called ECR. That means electronic control rope brake. Normally, our customer already have such rope brakes, but with weight, and when the beam getting smaller, the weight has to be changed, and that can be modified by a linear motor. And also in this equipment we measure the yarn tension with load cell, and so we can guarantee a constant warp tension from full to the empty beam. That's the end of my presentation. I would be pleased if I see you on our booth in Italy, and in this sense I say goodbye and meeting you next time in Italy.
Thank you, Walter.